Hey there. So I've had some questions about this first problem on the Chapter 10 homework, and I wanted to give you a video to walk you through at least the first part of it. So how this problem is set up is it wants you to use present value tables to figure out what the price of a bond is going to be when it's issued in the market. And it asks you to calculate the price of the bond based on a few different interest rates. One that is below the coupon rate of the bond or the contract rate of the bond, one that's equal to the contract rate of the bond, and one that is greater than the contract rate of the bond. So I'll walk you through the first bit, and if you set it up in Excel, you'll find that it's really easy to make adjustments, and if you do it in a calculator, you'll find that it's a little more time consuming, but it's not super hard. All right, so here we go with the question. Hartford Research issues bonds dated January 1st, 2015 that pay interest semi-annually on June 30th and December 31st. So the semi-annual bit is what's important. The bonds have $39,000 par value, that's also important, and an annual contract rate of 8%, that's also important. They mature in 10 years, that's also important. They've also given us 4 tables that we need to use to get the appropriate discount factor in order to find the present value. So I have them here, table 1, which gives us the present value of $1 to be received in the future. There's the formula. But present value, it's a financial term, but what it means in English is how much would you need to save today at a given interest rate in order to have $1 saved in this many periods. So if you have 5 periods and a 4% interest rate, you'd need to have 82 cents saved today. And in 5 years, that would be worth $1. And then here we've got present value of an annuity. Annuity is just a series of equally spaced payments of the exact same amount. And it's the amount of money we would need to save today in order to be able to withdraw a given amount, the amount of the annuity, each period at a given interest rate. So let's take a look at that question. We need to find N and I, and then we need to find the present value of the maturity value, the present value of the interest, and the sum of those two will be the price of the bond. Then we need to record the bond in our journal entry. And I'll walk us through the first bit where we've got a market rate of interest that's below the coupon rate, and then you'll be able to do the other two. So there's a few pieces of information we need. You can calculate this in Excel, but or with a calculator, but I like to use Excel. So we need to know our par value. Par value is the amount of money that the company is quote unquote borrowing. Based on the market interest rate, they may actually receive more than or less than that amount from the people who buy the bonds, but par value is how much they have to pay back. And in our case, it's $39,000. We also know that bonds are paying interest semi-annually. So that tells us that we make 2 payments per year. And our number of years, we'll call that maturity in years, is the number of years until they have to pay back the $39,000, and that is going to be 10 years. And the underwriters who have written the bond have decided that this bond is going to pay a contract rate of 8% per year. 8%, which means that the semi-annual contract rate, right, otherwise known as rate per period, or the semi-annual rate, is going to be equal to the annual rate divided by 2, right, the number of payments we have per year. So that means that these bonds are going to pay 4% interest twice a year. So what does this mean? Here's our let's do a couple of key takeaways here. is that we need to get N, well, no, actually, pause that, hold that thought. What we need to do next is figure out what the semi-annual interest payment is going to be. It's going to be equal to 4% paid every 6 months multiplied by the amount that they're borrowing. So they're going to have to pay $1,560 twice a year, regardless of what these bonds sell for. Okay, so let's move to this next bit where we need to calculate N, number of periods, or number of payments. And we also need to count I, which is the market interest rate per period. And in order to calculate I, we need to know what the market interest rate is per year. So here it tells us the market rate of the date of issuance is 6%. That means that since the company decided to sell these bonds with a contract rate of 8%, the interest rate has fallen. So now this is a really good interest rate compared to 6%, which is what investors could get someplace else. So back to N and I. N is the number of periods payments over the life of the bond. And that's going to be equal to the number of years multiplied by the number of payments per year. So we've got an N of 20. We could type it in here. And I is the market interest rate per period, which is going to be equal to our 6% per year, but we've got 2 periods per year. So we have a market interest rate per period, or an I, of 3%. So let's take a look at the rest of our table. We've got our par value at maturity is going to be, actually let's do it in Excel first. I'm getting ahead of myself. Let's take a look at our cash flows. We've got our table values. We've got our dollar amount, and then we can find the present value. So bonds have 2 different types of cash flows. They have the repayment of par when they're mature. So we can call that par, or the maturity value. And in our case, that's equal to $39,000. And the other cash flow are our interest payments, which come in the form of an annuity, right? Because it's every 6 months, $1,560. So cash flows of equal frequency and equal amounts. As long as that payment amount never changes and the spacing between payments doesn't change, we call it an annuity, and we can use that nifty annuity table. And that's going to be $1,560 every 6 months. So here's where we need our little table values. We'll go first to the one of the present value of $1. So our periods refers to N, and our rate refers to I. So we've got an I of 3 and an N of 20. So we go over to our I of 3 column, and we go down to our N of 20, and we get this number 0.5537. In English, that means you need to invest 55.37 cents today in order to withdraw $1 in 20 periods if the interest rate is 3%. But we can just type that in here, 0.5537. And then we go to our annuity table. We've got our I of 3 and our N of 20, 14.8775, which in English means you need to put away $14.88 roughly for each dollar that you want to withdraw at each period when the interest rate is 3%. Right? So you would be withdrawing $20 for each dollar that you deposited, but you would need to be, you'd be able to withdraw, was that English? For each, you would be able to withdraw $20 over 20 periods when the interest rate is 3% if you deposited $14 and roughly 88 cents today. So our present value of the par maturity amount is that discount factor times par, and the interest payments, it's the table value times the dollar of the interest payment. So these are the present value of those two items. So now we can use this data to fill in this table. So our table value 0.5537, amount 39,000, present value 21,594.3. So, and then for our interest, we've got a table value of 14.8775, an amount of 1,560, and a present value of $23,208.90. 23,209, sure it's rounding. And that means that the price of our bond is going to be equal to the sum of those two present values, otherwise known as $44,803.20. So how do we record this in the journal? Record the issue of bonds with a par value of $39,000 that they received for cash on January 1st. Assume that the market rate of interest is 6%, right? We already knew that bit. So we've got three things to think about. The amount of money we're going to receive, because people are going to be willing to pay a premium for these bonds. We've got the par value of the bonds, which is $39,000. And then we have the bond premium. And that's the amount that the company gets that's over the par value amount that they actually don't have to pay back, which is why we record it separately, because it's not part of bonds payable, because they just get to keep it. So these are our relevant numbers. I like them to all be in dollars. So we've got, first thing, we've got a debit cash because we're going to receive cash. And we're going to receive cash in this full amount, full price of the bond amount. So we're going to debit cash for $44,803.2. And then we're going to, what do we call this? Par value is $39,000. It's the amount we need to pay back. So we're going to call it bonds payable. And we're going to credit bonds payable because it's a liability for $39,000. And then we have our premium on our bonds. That's the amount that we received that we don't actually have to pay back. $5,803.20, right? And it may seem like, wow, we get this extra money that we don't have to pay back. Maybe we should offer a higher interest rate. Maybe it's better for us to offer to sell bonds at a premium. Well, the gist is that this is the extra amount of, this compensates us for the extra interest that we're paying when we're paying 8% when we only needed to pay 6%. So it seems like a good deal for the company, but it isn't necessarily. So this is the solution to the first part of question 10-1A. And I just want to check my work to make sure I don't have any typos. And assuming it's all good, which it is, I'm going to close out this video and you can email me if you have any questions. Thanks a lot.